let's talk about inverting operations. And when I say that, I just mean solve for x. If you're given an equation, solve for x. Get x by itself. Doing inverse operations. An inverse operation is just the opposite function that you're going to do to both sides to get rid of whatever it is. So for example, if we have all of these problems, right? In example 1, we're just going to do all these problems. So we're solving for x. So we will subtract 4 from both sides. So 3x equals 15, divide by 3, and x equals 5. Done. Let's do another one. We're adding 1 to both sides. So x over 5 equals -6. X is not by itself. We need to get rid of that 5. Remember, to get rid of a number in a denominator, you multiply by it. So we're going to multiply by 5. So x equals -30. Here we'll subtract 1. Oops. So we end up with x squared equal to 49. Now, to get rid of a square, we learned in Algebra 1 that you're supposed to square root both sides. So x is equal to the square root of 49, which is not 7, it's actually plus or minus 7. Because we took the square root, we don't know whether we started with a positive number or a negative number, so you have to put plus or minus anytime you take the square root of a number. We'll do that again in parts D and E. So, just in case you needed to see it again. Here in part D, we're going to get rid of the -5 first, so let's add 5 to both sides. So x plus 4 squared equals 25, and we'll square root. So x plus 4 is going to equal the square root of 25, which is 5, but we have a plus or minus. Well, now we're going to subtract 4 from both sides. So x is going to be -4 plus or minus 5. And we don't normally leave it like that, right? We're going to have x equal to -4 plus 5, and we're going to have x equal to -4 minus 5, because that's what those things mean. That's what those symbols are. 5 minus 4 is 1. -5 minus 4 is -9, which means my final answer is that x equals 1 and x equals -9. One more like that. Here we're going to subtract 2. So 5x minus 3 squared is equal to 9. Then we'll divide by 5. So x minus 3 squared equals 9 over 5. We will square root. So x minus 3 equals plus or minus the square root of 9 over 5. And then we'll add 3 to both sides. When you add 3 on any of these types of problems, I'm going to put my work right here. You just stick the 3 in front. So it's 3 plus or minus the square root of 9 over 5. And we'll just kind of leave it like that because 9 over 5 is not going to be a perfect square. So there's not a whole lot we can do there. Then we have something that looks like f. F looks nothing like anything we just looked at because the x is in the exponent. If x is in an exponent and we're trying to get it by itself, we don't have a tool yet to figure that out. So let's think about this. What does 2 to the x equals 9 mean? We're trying to find a number to use as an exponent for 2 that gives us 9. Now, logic says, oh, well, maybe we should try some numbers. Sure. 2 to the first power is 1. 2 squared is 4. 2 cubed is 8. And 2 to the fourth power is 16. None of those are 9. Having said that, we have 8 and we have 16. And 9 is in between them. So we know that this decimal of some kind, whatever the exponent is going to be between 8. It'll be between 8 and 16. And 9 is closer to 8 than it is to 16, so it's going to be closer to 8. Because 9. Well, not 8, sorry. That's not true. It's going to be between 3 and 4 because those are the exponents. So they're actually going to be between 3 and 4. It's going to be closer to 3 because 9 is closer to 8. If you graph these things, if you graph 2 to the x, which was our original function, and 9, you will find that it was 3.17. which is closer to 3. So that makes perfect sense. Now, that doesn't solve our problem, though, because we still don't know how to undo an exponential function. So let me show you how we do that. And it's very similar to how you take a square root to undo a squared expression. To undo a square, you take the square root of both sides, right? It's just an operation. So x is going to equal plus or minus the square root of 10. To undo an exponential, we take what is called a logarithm. So we're going to do log. We'll do log of that side too. So it ends up looking like this. It's log 2 to the x equals log, and it's base 2. Okay, so anytime you find a log of a number, there should be a 2 right here. There's a base. Okay, that's the little number at the bottom. And it's very similar. It's always going to be the same as the base on your exponential function, because this 2 to the x, that is your base. And that base is the same as the one here. Now what happens is, you know how the square root and the square, they cancel each other out? Log base 2 of 2, that cancels each other out. So x ends up being log base 2 of 9. And if you take log base 2 of 9, you throw it into a calculator, you're going to get 3.17 blah, 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 right? Because it's going to keep going. So we have to be able to go from a logarithmic function to an exponential, and an exponential function to a logarithmic function. And that's what we're going to practice right now. Now, you do need to know one thing in addition. If there's no base, the base is 10. So for example, for log x equals 5, that's the same thing as log base 10 of x equals 5. That and that, those are the same thing. We don't write the base when it's 10. We just don't. It's common, it shows up all the time, so it's not necessary. So now we're going to do some problems, and then we'll be done with the video. So we're going to solve the logarithms without using technology. The way we're going to do that is by changing this logarithm into exponential form. So first we're going to put this unknown x. We don't know what it's going to equal, so I'm just going to put equals x to all of these problems. I'm going to change it from logarithmic form to exponential form. The way I'm going to do that is by starting with my base. That's my base. I'm raising it to that power. Then it's going to equal that number. Okay, that's always true. That's how it works. Okay, let me do another one. My base for part B is 5. I'm raising it to the x power, because that's what was on the equal sign, on the other side of the equal sign, and now it's going to equal 5. Now my answer to these problems are what's the exponent? Well, 10 squared is 100, so x is 2. 5 to the first power is 5, so x is 1, because that makes the statement true. Then I'm going to keep going, right? So we have 6 to the x power equals 1 over 36. Now, when you were in Algebra 1, you were supposed to know, you're supposed to learn that 1 over something is the same thing as that to the negative first power, which means we really have 6 to the x equals 36 to the negative first power. Now, 36 is 6 squared, so that's really 6 to the negative second power, which means x equals negative 2. Here we have 2 to the x equals 1. Now, there's only one power of x that equals 1, and that is 0. It's the only one. It happens every time. Anything to the 0 power is equal to 1. So if you get a 1 on the right side, your answer is 0. Then we have 2 to the x equal to negative 4. Now this is an interesting fact. You cannot get a negative number from an exponential function. The only way to get a negative number is if there were a negative right here, and there's not, because the base was not negative 2, right? So this is actually, this x value is undefined. Sorry, we're going to need one more video.